Okay, so hi everyone. Thank you for the introduction. So my name is Meriem Belhad, and I'm glad to be here with you to walk you through the managed services Lustre on Amazon Web Services. So one of the most important decisions a business will make today is where to store their data. And AWS provides the most complete set of cloud storage. So AWS provides the most complete set of cloud storage for object, block, and file. And over the past few years, we built a rich set of data services, either services like AWS Backup to protect your data, AWS Data Sync, or the Snow family to move your data online or offline according to your business needs. And of course, once your data is on AWS, you can put it at work using machine learning services, analytics, and so on. So next, I would like to talk about three things that customers tell us about running their workloads on AWS. So first, customers love the ability to spin up virtually unlimited compute capacity to run their workloads in parallel and get results faster. The second thing we hear is that they like the ability to get access to that compute capacity in minutes versus months, and they like that the fact that they don't have to make large capital expenditures to acquire new compute for a single project or a limited period of time. And the third thing we hear is how organizations do their critical research work. In fact, AWS provides a simple and cost-effective access to compute, meaning that research researchers are able to run more experiments, trying new algorithms or approaches, which ultimately identify new breakthroughs because they are able to not compete for compute access with their peers or justify large capital expenditures for new hardware that may only be used for a short period of time on an idea that maybe is only half-baked. And these three things are really exciting for customers. And we want to highlight them and talk about how we make this possible for customers and what this means for the IT teams who support them. And the nice thing that we hear from our customers is that when you can experiment more and when you can create new ideas and innovate faster, you can turn your IT organization from a cost center into a value center. And this is a huge shift in mind. So customers also tell us that AWS scalable compute requires scalable data access provided by specialized storage solutions to maximize performance. And as you heard, I think, through the day and yesterday, performance is really very important for those compute-heavy workloads. And in an ideal world, your compute is always utilized to its full capacity. The more compute that you use, the more data access you have available to support that compute and make sure it's fully utilized. But in practice, and in the real world, it's not always the case. Sometimes you end up with a storage or networking bottleneck, and your workload will still running, but you don't get the most values of your compute resources, even though they are running on the cloud. FSx for Lustre is a fully managed service that we provide and is used by a wide variety of use cases, including big data, analytics, machine learning, high performance computing across different verticals. In high performance computing, FSx for Lustre is often used by manufacturing, life science, weather, energy, or media and entertainment customers who are bursting to the cloud for compute-intensive workloads. And in big data analytics, FSx for Lustre is often used as the high-performance storage solution for applications like SAS Grid or by ISVs who are building their own analytics as a service offerings in the cloud. And finally, in machine learning, FSx for Lustre is particularly well suited for enabling collaboration across scientists and builders, and customers tell us that it reduces the cost of compute in distributed machine learning training environments. Customers also tell us that one of the biggest benefits that FSx for Lustre offers is that it's a fully managed service. It means that we operate the service on behalf of our customers, making sure that your file system is secure, available, and its high performance meets your workload needs. And of course, FSx for Lustre is natively integrated into many popular AWS services like security, compute, orchestration, monitoring and automation, data protection, Amazon S3, and machine learning services like SageMaker. So now, let's talk about the value that FSx for Lustre brings to your high-performance workloads in terms of scalability, storage options, and data lake integration. So now let's walk through each of these, starting with the high scalability, scalable throughput capacity. In fact, with a few clicks in the AWS console or by using a single API call, you can create an FSx for Lustre file system with hundreds of gigabytes of throughput capacity and millions of IOPS. When you are done with it, you can just tear it down, and you don't pay any more for it. So it's pretty incredible from a performance perspective to be able to have that flexibility in your toolkit. But how does FSx for Lustre enable performance? So, well, FSx for Lustre file systems are built on a series of servers, and each have their own disks. And when you load the data into your FSx for Lustre, data is automatically distributed across all of the servers and all of the disks. And this is how we achieve that scalable performance. And Lustre scale-out architectures enable you to utilize all of the throughput and all of the network bandwidth for each of the servers aggregated together for your workloads. So now what we see if you look at what we are launching on the compute side is that we are launching EC2 instances with higher and higher levels of throughput. And because we have more powerful compute CPUs and GPUs that are more data hungry than ever, it's really important to keep all of these instances fed with data to run your workloads efficiently as possible. And this is why we see such a growing need for high performance storage. And FSX for Lustre is architected in a way that when you add more storage or more disks, you are also adding more servers. So performance is actually scaling with storage capacity. And larger file systems have more disks, more servers, more throughput, and more IOPS. But again, because of how Lustre is architected, Lustre file systems have consistent latency regardless of the size of the file system. So let's see what happens when you scale a file system. FSX for Lustre allows you to make updates to the file system after it has been created. So you can create a very small single node Lustre for a file system, and you can write your data to it. It all ends up on a single set of disks and in one server. But then you can choose in the future to expand the storage capacity of the file system. And in that case, we are adding 2 additional servers, and behind the scene, FSX for Lustre will automatically rebalance that data across multiple servers. And rebalancing means that FSX for Lustre will automatically move data from the older disks to the new disk, so that you get full performance of all these resources. And this all happens under the hood transparently, so that you get the full benefit, not just of the extra disks, but also of the compute and network resources in aggregate. So you see that also for big files, in case customers have bigger files, Lustre can automatically shard or stripe the data and then send it across to all these different servers. So when you write one large file, you are still accessing the performance of all of these resources. And similarly, when you are reading the data back, you are able to get the full throughput of the file system. And when the service team was designing FSX for Lustre service, they had to make a lot of decisions when they built and tuned the Lustre file system. And we believe that for the majority of applications, we've tuned them so that you don't have to think about Lustre. You get the performance that we have been talking about without figuring out how to build and maintain the service on AWS. So there is always some knobs that you have available on your end if you want to run and tune your workloads for specific performance needs that you have. So let's see a quick example. So the way that we have deployed our Lustre file system is that any file that is smaller than 1 gigabyte will be stored into a single disk. And any files that are 1 gigabyte or bigger are spread across 5 disks. And those are our defaults. And they will work for the majority of your workloads. But occasionally, we see customers who have bigger files and want to improve the performance even more. So they have the ability to not to take that 1 terabyte file, for example, and spread it across 5 disks. But they can spread it across a certain number of disks. So, for example, you can spread the file across your whole file system. You could increase this maybe to store the file into 8 or 16 disks. And the idea is to get more performance, of course, so that you when you are trying to read back that terabytes again, you are getting the full performance of all of these servers and disks. And it's configurable with a single command, and it's available on the client side without any other interactions with the service. So let's see this customer use case. So Shell is relying on high-performance compute for model building, testing, and validation. And from 2020 to 2022, GPU utilization on premises has increased around 90%, resulting in project delays and limitations on new algorithm experimentation. And Shell decided to augment their on-premises compute capacity by bursting to the cloud for additional GPUs and FSx for Lustre. And this solution gives them the capability to quickly scale up and down and only purchase additional compute capacity when needed. With EC2 and FSx for Lustre, Shell now has on-demand compute procurement with the scale and speed to respond to spikes in demand. And their GPUs are fully utilized, reducing the cost of compute and accelerating model testing. So now, we are going to shift gears a little bit and talk about how the FSx for Lustre service is structured and get into some of the major features and how customers are using them, starting, of course, with the topic that contribute most to the price performance. So FSx for Lustre is available in a number of different options and configurations. You can choose from HDD-based or SSD-based options, which, as you can imagine, give you a lot of flexibility in selecting the price performance you need. And there are a lot of different file system options, and if you are looking at replicated versus unreplicated, you are doubling the amount of storage, or at least adding a stretch factor into how much storage you will have to provision. So we are offering the SSD-based storage in two flavors: the persistent storage, so having an additional copy of your data, and the scratch storage, for which you have a single copy of your data. And more specifically, we have 6 options that are available in the current generation, starting at about the price of S3 standard, in case you are familiar with S3 standard. And the way FSx for Lustre is structured is that you get performance per capacity. So for example, if you choose 10 petabytes of the 12 megabyte per second HDD option, you get 10 petabytes capacity and 120 megabytes per second throughput. And if you choose 10 petabytes, if you choose 10 petabyte capacity with 1,000 megabytes per second throughput option, you get 10 petabytes capacity and 10 gigabytes per second of throughput. Okay, sorry. And now if you look at the right-hand side, you will see that the faster the option you select, the better the price performance gets. So your cost of bandwidth gets down the faster the option you select. And now, maybe you don't know upfront how much performance you will need, especially when you are starting a new project and you are you don't know from performance perspective how much you will require. So to support customers who want to be able to try multiple approaches and change over time, we announced a new feature called throughput scaling. So you simply change the file system performance level in the console, and the change is automatically implemented with the change in performance and price visible in your standard monitoring. And FSx for Lustre is increasing the maximum level of metadata IOPS, and you can drive on a file system by 15 times. And now we allow you to provision metadata IOPS independently of your file system's storage capacity. And you can choose to provision metadata IOPS using automatic mode or user provisioned mode. And one of the options that help our customers reduce costs and improve performance, of course, is to use compression. And with our LZ4 compression implementation, not only does our average customer see 50% compression, their performance can actually increase when they turn it on. And of course, using compression, you will reduce the amount of data you need to store for backups, because you only pay for used capacity. And Lustre stores only incremental change to the file system, which saves on periodic backup costs. And this is efficient in that the file system data is captured in seconds and transferred across multiple availability zones using free incremental bandwidth, and it also supports cross-region and cross-backup copy. So now I want to talk briefly about this customer use case. So it's Netflix. They are using large-scale distributed training for their own machine learning media models, and they use these models to generate thumbnails and trailers for thousands of videos and millions of clips. And they were able to take advantage of FSx for Lustre, and by adding some pre-computing steps in their data loading pipeline, they were able to speed training times by 3 to 4 times, reducing training times from a week to 1 to 2 days. So quickly, I will try to be quick here. I will discuss how FSx for Lustre integrates with data lakes. So FSx for Lustre provides a native integration with Amazon S3 that allows you to connect your S3 buckets to a Lustre file system, and you can import and export data either automatically or via a scheduled process or job. So we see that many customers start with a data lake and then utilize that data as a part of their AI/ML journey. And RAG, or retrieval augmented generation, works by integrating retrieval-based techniques with generative-based AI models. And we did a small test, so comparing between having the data into an EC2 instance and then using FSx for Lustre bucket by Amazon S3. So by switching from block storage in this case to FSx for Lustre, we saw that we no longer needed to copy data, which meant data download time disappeared. As soon as we have the training instance ready and the file system mounted, we could immediately access our data and start to train our model, speeding training. And by the time this was done, we could reduce the training time by 67% because we didn't have to move the data in advance, and we were able to scale up the performance of the file system to maximize throughput for our training instance, avoiding any kind of bottlenecks. And even further, when we ran the workload again, it was even faster because in this case, the data was already on the file system. So maybe to end up quickly with this great example of a customer who is using both file and object. Toyota Research Institute use S3 buckets with FSX for Lustre for their autonomous vehicle development program and for their broader data science environment, as well as for their machine learning training. So with that, thank you for your time and attention. So any questions?
Thank you for presentation. So you gave, sorry. Okay. Okay, so you gave some examples of workload, and I'm interested in another one. So assume we need to share a Git repository. So 30 gigabytes of small files. Whether such solution can allow to mount a lot of clients and quickly Git clone, for example. What do you think?
So you have 30 gigabytes files?
Small files, very small.
Small, very small files. So yeah, in that case, I think we have the defaults to store those. So each file will be stored into a single disk. So yeah, maybe you need to test if FSX for Lustre is the right solution for you, and otherwise we provide other file services that might be relevant in your particular use case. I already had multiple discussions with customers who are in fact experiencing some challenges with very small files, and yes, we need to dive deeper into the use case to understand how you are accessing your files and how we can optimize performance.
Thank you.
Welcome.
So if a customer has some performance issue, the characteristic of a workload, do they have a way of detect and tell AWS to tune the server to adapt?
Yes, of course. In fact, as I explained, FSX for Lustre is integrated with the AWS ecosystem, and it integrates with our monitoring and auditing tools like CloudWatch. So you will have access to the logs to be able to identify any issues. And of course, we as solution architects and the AWS support can also help you in case you are facing, you are not able to identify the issues by yourself.
Do you provide online upgrade, meaning the workload continue while the server being upgraded? Yes,
absolutely. In fact, with the new feature that we announced, you are able to scale throughput up and down online.
No, I mean the server upgrade the Lustre version.
Okay. So for the Lustre, it's the job of AWS. So we have a shared cloud responsibility. We are providing you with a fully managed service. So we take care of all the software upgrades, the hardware maintenance and replacement and upgrades. So it's up to us to perform those upgrades on your behalf.
But you will take a downtime.
Sorry?
But you will take a downtime, meaning service interruption.
No, of course not. We don't want to impact our customers, so we do it in a transparent way. And now we are using the version 2.15 of Lustre. And of course, in case we are planning to have any upgrades, we inform our customers about the target version, and we keep you in the loop.
So during this upgrade time, do you take the server offline, or you have some failover mechanism to guarantee the Lustre always being mounted?
So of course we are using a highly available infrastructure, and under the hood we will take benefit from the high availability of our infrastructure to make it transparent to our customers.
Okay, thank you.
You're welcome.
What's your contribution to the ecosystem of Lustre in terms of R&D?
Sorry, I don't hear.
What's the contribution of AWS to the ecosystem? Oh, sorry.
Sorry, was it about the integration into
The contribution.
contribution?
Does your work show up to the community of open sourcing? Do you open source?
Yeah, so I can say Tim Day from AWS is a regular member of the Lustre working group, and he does do a number of patches, mostly running Converity on the Lustre code base and dealing with issues it finds.
Okay. I have a question about the version of Lustre you are based on and what you provide to your customer. Can the customer choose a specific version? This is just FSX, and you don't know what is under the hood, right?
No, because it's our responsibility to maintain and make sure that our service is available for our customers. So it's really our responsibility to choose which version, but of course, take informed decision on which versions we choose. And this is a fully managed service. So this is the difference between having your own workload or your own Lustre running on. You can, for example, use EC2 instances to run your own Lustre service, or use AWS FSX for Lustre fully managed service.
I was thinking about features you have just in some Lustre version accessible to the client. So you provide this feature, and this is just your stuff to provide that to the client, but the client cannot choose this feature.
In fact, of course, we provide our users with some, in fact, possibilities to tune their file system. So, like the example I discussed earlier about choosing to use higher number of disks to store your big files, for example.
Or in terms of configuration of the file system.
Yes.
Okay, right.